Hi, and welcome back to Exemplary Marketing's YouTube channel. Today, we're going to be talking about the 5 steps to building a cloud-ready application architecture. Here's how to build a cloud-ready application and the application architecture concepts that you're going to be needing to succeed. Anyone who's built applications understands that applications designed specifically for the platform on which they'll run will perform better and are more resilient and easier to manage. However, few people understand exactly how to go about designing and building a cloud application architecture for private or public clouds. This lack of skills and experience has led to poorly designed applications for cloud-based platforms. These applications don't deliver the value on the cloud platform that enterprises expect. The process presented below represents a step-by-step approach that mixes traditional software development concepts and reviews what's new with the cloud. It's a collection of best practices, concepts, and procedures for success. Number 1, design the application as a collection of services. Cloud applications are best deployed as a collection of cloud services or APIs. You build up from the data to the services and then combine those services into composite services or complete composite applications. This is service-based or service-oriented architecture at its essence. While many understand the concepts, developers still have a tendency to create tightly coupled applications that focus on the user interface rather than expose the underlying functions as services that they can leverage independently. When developing an application architecture for the cloud, you deal with complex distributed systems that can take advantage of loosely coupled applications built on many services that can also be decoupled from the data. See Decouple the Data below. You can separate the application services physically, executing on the proper machine instances and service/API managers, and governance technology that provides services directories that can help track the many services that make up your application. Additional benefits may include service reuse from other applications or more coarse-grained services. You can break up applications into hundreds of underlying services that have value when used by other applications. In this way, you're not reinventing the wheel each time that you build an application. Consider the example of a credit check service that many applications use. Combine these into a single service, and the application becomes much more efficient. 2 is to decouple the data. If you tightly couple the data to the application, it won't find a good home in the cloud. Private and public clouds are complex distributed systems that work best with application architectures that break out processing and data into separate components. You decouple the data for the same reason that you want to build the application out of services. Once decoupled, you have the option to store and process the data on any public or private cloud instance. For example, many enterprises insist that their data remain on local servers, but want to take advantage of the commodity virtual machine instances within a public cloud. You must consider performance. Database reads and writes across the open internet can cause latency, and database communications may determine how close your data sits to the services and applications that need to leverage it. Consider using caching systems. These provide additional database performance by locally storing commonly processed data, thereby reducing all database read requests back to the physical database. Those are best built into the application, however, and they should be tested with the application data to determine how efficient the cache is going to be. Systems that are constantly reading new data don't benefit as much from database caches. 3. Consider communications between application components. Decoupling applications, both data and services, doesn't mean that your application is properly architected for the cloud. Chatty application components that constantly communicate with each other are going to lower the performance of the overall application, given that they're typically distributed over a network or the open internet, where tolerance for high latency is desirable. Focus on designing applications that optimize communications between application components. For example, combine communications into a single stream of data or a group of messages, rather than constantly communicating as if the application components reside on a single platform. 4. Model and design for performance and scaling. Designing for performance means first building a model that is going to represent how the application behaves under an increasing load. If 1,000 or more users log on at the same time, how will the application handle the increased traffic on the network, the increased load on the application servers, and the load placed on the backend databases? You need to understand how application components handle the load as the number of users increases to 1,000 or more users. Armed with this model, you can figure out how best to scale the application by automatically spinning up resource instances that are needed. In some cases, cloud service providers offer auto-scaling capabilities where provisioning occurs automatically. The most efficient path, however, lies in understanding the application's workload profile and defining the path to scaling the application, as well as putting mechanisms in place to ensure that it will indeed scale. Finally, monitor overall application performance using application-aware performance monitoring tools and create interfaces within the application to better enable performance monitoring. How the application provisions and deprovisions resources should be innate to the application as well. 5. Make security systemic within the application. Pick a security approach and technology prior to building your application that will be effective for the type of application that you're running and that's going to address any compliance or other data level security issues. If you're in healthcare, for example, you must consider personally identifiable information as well as the Health Insurance Portability and Accountability Act, the HIPAA, in the US. You'll need to store data in certain ways on clouds that are HIPAA compliant. Moreover, the application that will need to handle sensitive data in specified ways with required levels of security such as encryption. Your core objective is to design security into the application and take advantage of the native features of both the cloud and the IAM system that you use. However, each application has its own requirements based upon the needs of the business, and security always differs from one enterprise to another. In summary, building a cloud-ready application architecture requires that you pay attention to a few new things, but many of the traditional concepts are still important, such as sound design, testing, and learning from your mistakes. Most developers who deploy applications on private or public cloud platforms will make some blunders, but as long as they recognize, correct, and learn from those mistakes, they'll be well on their way to finding a more effective path to building applications in the cloud. Be sure to follow the 5 steps to building a cloud-ready application architecture, and that's it for today's video. If you learned something new, make sure you drop a comment down below in the comment section, and don't forget to hit that like button. Thanks for watching, subscribe for more.